Hey guys, I wanted to show you about this project that I've been working on Minecraft. It allows you to take three two-dimensional pictures of the single object on each axis XYZ, run it through this algorithm that I wrote here, and then it uh, figures out where the object overlaps with itself and then maps that three-dimensionally into Minecraft. So to start off with something real simple here, we will check out this little test that I have. Okay, so this is our object. Anything that's bright pink is going to be removed. So this is the front view, that's the side view, and then the top, and so this is just generally going to look like kind of a silly little spaceship here. But that is what we're going for, so we'll go ahead and run this guy. And so that goes through, does the calculations, and then writes out the Minecraft file format, and then we can go in here to my world, run it, and we got this object chilling out here. So you can see it tries to do a little bit of coloring. There's a lot more logic to actually make the coloring work correctly in here, and frankly I just don't care, because what I wanted to do was map three-dimensional objects into Minecraft, which this does. So that's our little tiny spaceship here, which is neat, but I wanted to do something more real after seeing the guy who did the Starship Enterprise, because that was pretty damn cool. So I'm kind of a BSG fan, so I went ahead and got images of the Battlestar Galactica here, so we don't care about that one, but we do care about this one. I do want to point out that the depth and the width of the Battlestar Galactica are one-to-one represented inside Minecraft, but unfortunately Minecraft, the game, cannot handle how tall the Battlestar Galactica is, so I had to cap it at 128 blocks, whereas on this scale the thing would actually be 187 blocks high in order to be correctly scaled, so it's a little squeezed, but it works. So there's the front, there's the side image, and there is the top, and so those will be the three images that we use. And we'll go ahead and run this guy. Helps if I'm in the correct directory here. And it also helps if I copy the files across. Alrighty, so this thing's chugging along. This will actually take long enough to where you guys aren't going to want to watch this, because it has to calculate these 120 blocks, and then writing out the Minecraft format is going to be a little slow. So I'm going to pause this video and we will resume when this gets done. Alrighty, so we are now done rendering out our Battlestar Galactica. I'm hanging out in this same little world here. Let it kind of roll in. And we'll start walking up to it now. The images that I use, since I just got them off the web and just kind of slapped it together, the edges are not as smooth as they should be to create the kind of effect that we really want here. But the you get the general idea, and also you can start to get the feeling of the scale of how freaking huge this ship is. It's well, it's a monster for sure. I guess while I walk down this thing, I'll talk a little bit about what we did here. So, from scratch, I wrote a little C++ interface to read in the maps. I based everything off of Qt because I love C++, but I'm not a huge fan of the STL. And the performance is comparable or even better with Qt, so I found, and so that's what I used. I use Qt for the hash and list operations that are required, and also the image reading just kind of a freebie win. And then once we had the images loaded in, just did some real simple calculations based on the color that each 3 images represents, and cancel out what blocks should be there and what blocks shouldn't be there. And then once we have that map, then I convert it into the 3-dimensional Minecraft coordinate system and then output it to the file system. So it's a pretty simple task. We're just past the first part of the ship here, that front, and now you can see one of the 2 hangar bays that this monster has on it. On down. So this technology, which I am just going to throw up on GitHub so anyone else can play around with it and waste their life like I have with it, but it could really be used for just about anything you could dream up. I was thinking that you could make some kind of crazy level system, or who knows, if you know just about anything about C++, the code is pretty darn simply written, and so it should be easy to get in there and edit it. I don't know, I mean, I guess like the potential to make the biggest roller coaster ever is there, or all kinds of different stuff. This project originally started out that I wanted a better way to do Minecraft redstone circuits, do it a little bit faster than trying to edit that stuff in the game. And that part of it does work, but once I got it working, I was like, well, crap, I don't know what to wire up, so I kind of switched over to do something on a little bit bigger scale here. So we're about halfway down the ship right now. And as you can see, I mean, I've got my render distance on far. This ship is just so ridiculously huge that the game, it can't even show you what we're really looking at here. But that's the second hold there for the hangar bay. Something else of note is the algorithm. When in order to do my pixel comparison, I convert everything into HSV and then map that into a 3-dimensional XYZ coordinate based on the color cone that HSV represents. And then at that point, with those 3-dimensional coordinates, you can just do a simple distance formula calculation and figure out how close one pixel's color is to another. And that's all well and dandy, but I made no efforts when I was writing that code to optimize it. And so for doing a huge image like this, it probably takes maybe a full minute to do that calculation, and then after that, it takes 2 or 3 minutes to do the G-zipping is actually the slowest part, but to output those Minecraft file formats. Alright, so there's the end of the hangar bay, and now we're starting the engines back here. Actually scoot out a bit, see if we can get a little bit better sense of what we're looking at. My point is, though, is that this system that I run off of is an i7, and so it's pretty easy to just parallelize it and run 8 threads at it. But if you're on a slower system, it may be worthwhile to do some real simple things like remove the square root operations and turn some of the functions into pound defines or pre-cache the colors, the 3-dimensional coordinates of the colors that are used repeatedly. It's just very simple optimization things that I just didn't really care to try and do. Alrighty, so now we're to the end of the ship here. We'll finally get to see where the engines are. There's an odd thing that there must be some glitch or something like that in the images I'm using, because this last row of pixels right there comes out as that flat line, which is odd looking. But so anyways, there's the lower engine nozzle. That's an artifact there of the image. If I took the time to edit the images out and made them smoother, that wouldn't be there. And then that top huge thing protruding out is the other engine exhaust there. And now we get back into the real world here that we have not hacked up. So Minecraft is going to take its time to render all that out. So the one last thing that I'll show you guys here is just trying to get an idea of how wide this thing is. So we'll start walking across the width here. So really, if you think about the number of calculations the system has to do in order to dump this stuff out, and that it can get it all done in about 2 minutes, and it's pretty poorly the algorithm is pretty poorly optimized. It's still is running pretty darn fast. Alrighty, yeah. So those are your 4 engine exhausts here. The one thing which I did start doing, I just kind of gave up, is that the images themselves obviously represent a texture map that can go over the 3-dimensional object. Excuse me, and I made a few very small simple attempts to take those colors and then have that be what's represented on the outside of the ship, and it kind of works. But what you really need is you need 6 images. You need the front, back, rear, both sides, top and bottom. And then the closer that you get to the edge of the 3-dimensional shape, whatever edge that may be, then you have to more heavily weight one image over the other. And frankly, that kind of thought makes my brain hurt, and I didn't want to spend the time in debugging to figure out what that would take. So it's got a much more simple algorithm to figure that out. But anyway, so that is the width of the ship, and then as you could imagine, if we started walking down there, we'd see the other side of it, and this side is the one that has the open hangar bay that everyone was coming and going out of, whereas the other side is the museum. So there it is, the rear end of the Battlestar Galactica. Hope you guys like this video, and I'll go ahead and post all my code up on GitHub, and hopefully somebody else can do something else cool with it. Thanks for watching, guys. I appreciate it.